This is the rubber banded blocks station. So I have 2 blocks of wood, and they're rubber banded together. And if you get a good grip on them, you can kind of pull them apart a little bit, but they go right back because of the tension in the rubber bands. So if you want to try and split these and separate them apart and keep them separated, you could either kind of cheat and cut the rubber bands, or you can use something to try and get in between these 2 pieces of wood. So I've got a couple options here, like this screwdriver, normally used to screw stuff in, but in this case, I can get it in between here. Okay, and I can use the point of the screwdriver to get in between the 2 blocks and work that in between. And it does pretty good. It's pretty easy to get it in between the blocks, but it doesn't separate them a whole bunch. So let me pull this out. Let's try another option. Okay, this guy is a wood chisel. Okay, so let's see how this one does. Okay, that got in pretty easily. It's got a nice tapered edge to it. But again, once we hit to the handle, if I squeeze it in kind of past there, it can work a little bit more, but it doesn't spread out a whole bunch, at least not without me having to put an effort to try and, pull the blocks apart to squeeze it down farther under the handle. So this last one is called a trim puller. This is a fancy little piece of equipment you can use to pull off trim in your house. That's supposedly not supposed to damage it. So it has an edge, kind of like the wood chisel does. Okay, let me see if I can get it kind of close to the screen so I can show kind of the side-by-side profile. Okay, so it's got that kind of edge, but it also has this extra kind of part sticking out here. So when I go and drive it in here, this pushes it way farther out, thanks to that extra kind of ramp there on the part of it. Okay, so what simple machine are these guys acting as? Okay, we're using the edge here to be able to split and separate these 2 things. This is the nutcracker station. This is my nutcracker. I've got some peanuts here. So this is pretty simple to use. All you have to do is get a peanut in between the jaws of the nutcracker, and then you just press down, and it cracks it open. Okay? Now, peanuts themselves aren't super hard to crack with your fingers, but it does definitely make it easier to do when you've got a simple machine at your disposal, especially if you get it into this little top part here. Boom, like that. Okay, and this can be really helpful for other kinds of like almonds and macadamia nuts that have a harder shell. Okay. So we want to try and figure out what type of simple machine this is. Ooh. Now we have a pivot point here. Well, this can kind of rotate on. We also call this a fulcrum. So this has a fulcrum. And it has 2 arms here that we can push up and down. Okay. So what kind of simple machine would that be? If it's got this pivot point, this fulcrum, and I have this kind of shape that I can press together, I can move, change how these rotate around that fulcrum, what would that be? This is the station sliding a brick, and we're gonna slide a brick. So I've got a spring scale here to measure force. I've got a brick attached to a string that I'm going to try and slide across these boards. Okay, so if I hook this on here and I pull, okay, that's about 8 newtons. And we hit a rough patch. Okay, that's taking a full 10 newtons. I'm like maxing out the scale. Oh, I gotta get over the edge here. Yeah, it's taking about between 8 and 10 newtons to slide that across, which is a considerable amount of force. It's definitely doable, but it's significant. Now, if I wanted to try and move this in an easier way, I might use these guys here. These are little wooden dowel rods that I've cut down, and they roll pretty nicely. So if I try and set the brick on here, and then try and pull this, oops, here we go. Oh. I think the highest number I got was 2 newtons, but most of it's just going about like 1 newton to maybe a half a newton just to roll it across here. So like 8 to 10 times easier than what I was doing on the board here, which is pretty significant. So it's a lot easier for me to move the brick if the surface can kind of roll with it. So the question is, what are these guys acting as? What kind of simple machine would these guys be if they're able to roll like this and allow this guy to roll on top of it? Okay, this is the hand drill station. This is probably the kind of drill you're more used to in these days. It's electronic. It uses the power of a battery to turn this guy. But you can also do this by hand. So this hand drill still has the same idea. We have this spiral-shaped object that we use to carve into wood, but instead of having a motor turn this over and over and over again, we're going to turn it over and over and over again with our hands, like that. So I'm going to put this up on the wood. I'm going to press down on the top part here, which might be out of the view of the camera, but I'm pushing down this part here, which can turn. All right, and then I'm going to twist this. You can hear the blade of this spiral ramp carving into the wood. Okay. So the spirals help to make the cut as well as to pull these little wood chips and filings out of the hole that I've made. Okay. Now, if you don't get this one to work, it might be because you're going the wrong direction. Like I can press down as hard as I want, but if I'm not pulling the edge of the ramp in the correct direction, it's not going to cut in. So if it doesn't seem like it's working, you don't know why, try turning the other direction and see if that works. This station is the Build-A-Gear setup. So I have some gears here, and I'm going to make a setup of these gears that allows me to turn one gear using another. So a gear like this is kind of like a lever, where I've got an arm on one side and an arm on the other. And if I push down on one side of the lever arm, it turns the other side. Okay, where this would be like the fulcrum of the lever. But this is a more specific version of the lever. Okay, so you can kind of knock that answer out and then look for something that's like a lever, more specific. Okay, the way that this moves might help you kind of figure out which version this is going to be. Okay, now I can, again, set these up so that they can turn each other, so that if I move this green one, the red one also moves. I could put this blue one here so that I could move the blue one to cause the red and the green to move. I can connect up the purple one and the yellow one. So that way when I turn the yellow one, all of them move, like so. Okay, and you can make these into a lot of different arrangements. I kind of like putting the big one in the middle and having a bunch of little ones off to the sides, like that. And you can watch and see how fast the smaller gears turn compared to the larger gears. How it takes longer for this guy to go all the way around. Oops, that's stuck. Compared to how many times this guy makes a full rotation. Okay, so try and figure out what kind of simple machine each gear is acting as. Okay, this station is ramping up a weight. So this is a 500 gram weight. It takes roughly 5 newtons of force to lift this straight up. Okay, that's what my spring scale is showing me. Okay, now if I don't want to have to put in 5 newtons of force, I might have to use a simple machine to decrease the amount of force that I'm putting in to lift it that high. So if I want to be able to lift this guy this high, okay, but I don't want to have to do it on my own, I might use something like this ramp. If I set this guy on its side, and now I pull this way instead of straight up, and that takes about 2 newtons of force. If I get stuck, kind of 3 newtons, but it's definitely less than 5 newtons. Okay, so by not having to pull it straight upwards and by pulling it for a longer distance this way at a lower angle, it only takes about 2 to 3 newtons of force compared to the 5 it takes to go straight up. Okay, so the question is, what type of simple machine is this? what do we call the ramp? What's another word for it? All right, this station is weights along ropes. So I've got a couple of fishing weights hanging here, this guy and this guy. And if I want to move them across a rope, I could do it in a couple different ways. One of them is to have this metal device here. Looks like it has kind of a roller on the inside. And when it's hanging down on this rope, it can glide along it pretty easily, like so. I also have this guy that's not on a roller, but I can pull the string one way or another, and the rope or the string is what ends up moving on this roller here. Okay, so either I can move the weight by putting something like a roller on the rope itself, or I can use the roller to move the rope or the string itself rather than moving the weight on its own. Okay. In either case, we're looking for what we call this simple machine right here. This guy and this guy are both called the same thing. So what would we call these? Okay. This is the pulling and setting nails station. So I've got a hammer that I can use to set nails, and I can also pull them out. And I've got some nails to work with here. Okay. So whether I am setting the nails and hitting them like that, or whether I am pulling them out like, if I can hook it, that, okay, I'm using the hammer as the same kind of simple machine, okay? In this case, I rotate the hammer on this end where my hand is basically acting as the fulcrum, okay? I'm delivering the force, and I'm changing how much force I apply and what direction I put it in by using it. When I turn this around, and I use the claw end, okay, now my fulcrum is down here. I pull back here to be able to change the force's direction to up, like this. So I pull back, the hammer claw pulls up, and it pulls the nail out. Okay. In either case, it's all based on using this with a fulcrum, either down on the handle, or by using it with the fulcrum down in the middle part of the head. So try and figure out what simple machine this would be classified as. This is the splitting a sea of rice station. So I've got my sea of rice here. I'm going to try and split down it by using these 3 blocks. So first up, it's going to be this squarish one. Kind of pile up my rice over here first. And kind of scoot some of it back. Okay. To keep track of how easy or hard it is to pull through this sea of rice, I'm going to use a spring scale here. I'm going to kind of hold the back so that way it doesn't tip upwards, otherwise it kind of like falls over. Okay, so that's taking about 1 Newton of force. As it piles up, it's more like 1.5 newtons. Not quite 2. It's about 1.5 newtons. So not a lot of force, but let's see how it compares to the others. Okay. Next up is this guy, which is kind of like the square block, except it's got a point on it. Let's make some room. Put this back. All right. And see how this goes through. Oops, let's turn it to the force in Newton side. So again, I'm going to kind of hold the back so it doesn't flip over. Okay, so that's taking maybe about 3/4 of a Newton to 1 Newton. Okay, when it's kind of piling up over here, we're at about 1 Newton. So a little bit less force is needed for this kind of triangle shape here. And then we've got a sharper triangle for the last one. Okay, so last one, we're gonna hook the spring scale on here. Hold down the end. Okay, so we're reading about 1/2 Newton. 1/2 Newton, around somewhere between 1/2 Newton, 1 Newton. So pretty close to the same as this, maybe a little bit less force than was needed for this guy. But it seems like this triangle end here is definitely helping to split the rice onto either side instead of having it all stack up like that. The more we have on this side, the more we have to push against. If we can divert it to the left or the right, like along this way, instead of having it all pile up on the end, it's a little bit easier to cut through. Kind of like a knife. All right. So, the question is, what kind of simple machine would we call this that allows us to cut through and split through the rice? Okay, this is the scraping up wax station. So here I have some wax that I've allowed to cool on the surface of this tray. I've got a couple scrapers of different sizes, but they have one thing in common, and that's this edge right here. We can kind of scrape some of the wax off of it. So it's got kind of an edge to it that gets thinner as you get towards the top. Okay, that allows me to get in between the wax and the surface it's stuck to. So I can lift it up and scrape it off of the tray. A lot easier than just trying to pick at it at my fingers and getting little pieces off. Okay, then once I've got the pieces scraped up, I can put them back in here to have them remelt for the next group. So the scraper is really similar to this wood chisel in its shape, and this is a little bit easier to see the taper of the edge here. So think of the scrapers like this guy right here. So what kind of simple machine would these scrapers be acting as to split and get in between the wax and the tray? This station is spiraling against gravity. So I've got my spiral here. Okay, we're gonna use it to fight gravity here. So note the shape. It's kind of like one big long ramp that keeps going and going and going. But it goes around this one single rod, or this one single pole, the stick. So from afar, it might just kind of look like a bunch of little circles, but it is really one big ramp that goes all the way up, okay? And I can use this to my advantage to move things. So I've got some BBs here. I want to try and get them into this dish, and instead of having to lift them manually and pick them up and drop them in, I'm going to use the spiral to help me out. So what I'm going to do is I'm going to kind of get these into a corner pile. Okay, kind of get them stacked up. I'm going to shovel this in the end here. Okay, and I'm going to start turning the spiral. And you can see that I'm starting to pick up the BBs here. Okay, once they get to the top of the spiral, they'll drop out. Out of the top here, like so. Okay, and it makes room for the next set to be scooped up. And I can keep going and going and going, as long as there's still more BBs at the other end that I can continue to scoop and scrape up. So the question is, what is this shape inside here? And how does it allow me to pick up all these BBs? Okay, what would we call this simple machine right here? Something I've never really liked doing is coiling up cables when I'm done with them. So when I've got a wire that I'm ready to pack up, I've got to kind of, put it into a loop so I can store it. But I always end up with these like terrible parts that you have to try and figure out which way they're turning, or else they end up tangling. And then the more you do, the heavier it gets. And so by the time you get through like an 100-foot or 200-foot cable, your arms are sore and it's just a huge pain. So I've got a simple machine that can make that job a little easier. This guy is a cable reel, okay? Got this part here that can rotate. Okay, and as I rotate this handle, it picks up the cord and pulls it into this bundle, like so. So I don't have to do all the work of trying to coil it myself. All I have to do is put this out in front here and twist this up. and it just slurps the cable right in. Oops, I went the wrong way. Like so. Then I'm done, which is way easier than having to do it by hand. So the question is, what type of simple machine is this guy right here that I'm reeling in with the handle? This station is the meter stick lifters, where I have meter sticks here that are rubber banded to my sink faucet. And if I lift up on one end of the meter stick, I can move the weight on the other side. Okay? Now, if I want to know how much force it takes to lift the weight on the other side, I can hook this spring scale to this end so that as I pull down and I get the other end to come up, I can read the force on this side of the scale. All right, so just to get it off the ground, it takes about maybe like 3 1/4 newtons, 3.25 newtons, okay, to get this guy off the ground. Okay. Now this guy is a 500 gram weight, so it takes about 5 newtons to pull it straight up. Okay, so this simple machine has decreased the amount of force that we have to put in to lift the object, which is nice, but we might be able to decrease the force even more. So let's try it with this lever next. I'm going to put it on this shorter end over here. Like so. Then I'm going to hook my spring scale to this end over here. Okay, so that as I pull down, I should be able to see how much force it takes for me to pull down this way to lift up the object this way. Again, lifting it normally straight up would take about 5 newtons. This is taking about 1.5 compared to like the 3 1/4 for this one. Okay, so quite a big difference. Okay, now it's up to like 2 newtons or so, but that's still quite a bit less than the 3.25 newtons it took to lift the weight with this guy. Okay, so what kind of simple machine is this where we are pivoting on this point here or on this point here? This is the wind gyro station. So the wind gyro is this guy right here. It's got a magnet on the bottom of it, so it sticks to this little platform. And it's got this cool shape. It's kind of a spiral shape that allows air to flow through these grooves to curve around it. That can cause forces to make this guy turn. So you can try and spin this guy like a regular top, like that. Or you can do it the way that's a lot more fun, which is to spin it using the power of air. So I've got a straw here to kind of concentrate the air directly down on top of the top, on top of the wind gyro. So that way I can get a huge blast of air to hopefully spin this guy. So here we go. Like that. Hey, look at that go. This station is called the block and tackle. So I have a couple versions of the block and tackle set up. This is a single block and tackle, and this is a double block and tackle, where you've got the block being this metal part here with this roller on the inside, like this guy, and the tackle being the combination of the blocks and the ropes that we have together here. Okay, so these are both 1 kilogram weights. Typically they take 10 newtons to lift. In this case, I'm going to lift this one using the block and tackle system I have here. Try and turn this so that it aligns well. There we go. All right, and I've got a spring scale on this end. So let's see. Okay, that's about 7 or 8 newtons that it's taking to lift that, which is a little bit better than the 10 newtons straight up that it would normally take. Okay, let's try this one. So let's hook this onto this guy here. Okay. So again, I'm going to pull down with the spring scale. Okay, this one's coming out to be about 6 newtons pretty consistently, which again is quite a bit less. Right? In both cases, I end up with less force than required to lift these guys. What's also similar between these is that I'm changing the distance I have to apply these forces. So put this guy on there. Let's see if I can get these both at the same time. So let's hook that there, onto this guy, and then let's hook this guy on here. There we go. Okay, so if you watch how much rope I pull on each of these, right now they're both about on the table. So I'm going to pull my hands down or pull back the same amount. But notice how the one on the right, well, I guess your left, is going higher, even though I'm pulling the rope the same amount. Okay, I have to pull a greater distance of rope for this one over here. Okay, to get it to be the same height, I got to keep pulling. But this one takes less force for me to move. This one is a little bit tougher. Okay, the more of these block and tackle setups you have, the more rope it's going to take to pull your weight through, okay, and to lift it, but the easier it's going to get. Okay, so the question is, what do we call this block part? What kind of simple machine is this if we've got this roller in the middle that we can pass rope through or string through?